In this example, we need to solve the equation 9 raised to the 4x minus 5 equals 27 raised to the 15 minus x. Well, what type of equation do we have here? The variables are in the exponents, so we have an exponential equation. The simplest form of exponential equation to solve are those in which we can write both sides with the same base raised to different exponents. And if we can do that, we then use the one-to-one property for exponential functions that says if b to the x equals b to the y, then x equals y. So that is our goal, is to write the equation in this format. Looking at our two bases, we have 9 and 27. 27 is not an integer power of 9, but both 9 and 27 are integer powers of 3. So if I write both sides in terms of base 3, then I should be able to use this one-to-one property. So 9 is 3 times 3, it's 3 squared. So I'm going to have 3 squared all raised to the 4x minus 5 equals 27 is 3 cubed. It's 3 times 3 is 9 times 3 is 27. So I'm going to have 3 cubed all raised to the 15 minus x. So now, remembering the rules of exponents, if you have 3 raised to an exponent that is raised to another exponent, what do you do with these two exponents? You multiply them. So I'm going to have 3 raised to 2 times 4x is 8x, and 2 times negative 5 is negative 10, equals 3. Now I'm going to multiply these two exponents. 3 times 15 is 45. Then 3 times negative x is negative 3x. So now I've finally written it in this format. I have 3 raised to the 8x minus 10 equals 3 raised to the 45 minus 3x. So our two exponents have to be equal. So 8x minus 10 has to equal 45 minus 3x. So now, instead of an exponential equation, I have a simple linear equation. So we're going to solve that by adding 3x to both sides. And we're also going to add 10 to both sides. So I'm going to have 8x plus 3x is 11x equals 45 plus 10 is 55. Last thing I need to do, divide both sides by 11. I get x equals 55 divided by 11 is 5. So the solution to this equation is x equals 5. Now, do I have to check for extraneous solutions? No, we started with an exponential equation. We don't have to check those for extraneous solutions.